Hello and welcome to another exam paper walkthrough. So I'm continuing with my Edexcel series in today's video. Some of you might be aware that a few weeks ago I released a predicted topic paper ahead of the summer 25 exam series. So I spent quite a bit of time writing that paper based on topics that typically hit on paper ones. If you've not already done that paper and that video, I would recommend you do that first because this is a shadow version of that paper. So what I've done is I've taken all of those questions and I've just rejigged them a little bit. If you've not already done that paper, either of those papers, attached to the description to this video, you'll find a link to a Google Drive where you can download a copy of the paper and do it beforehand. There's also a copy of the problem pair version, which is where I've taken the solution for my original paper and combined it with the shadow questions just to give you a bit more structure for your own solutions. Again, I would recommend you do those papers before you watch this video. There's a copy of the paper. It's the one that says shadow rather than not the word shadow. Or the problem pair version. This will be relevant for the problem pair or the shadow, depending on how much support you want with the solutions. Again, like I said, this is for the June 25, and this is a paper one higher. So this is a higher tier. There are the foundation tiers as well. They're on a separate playlist and a separate Google Drive. Feel free to do whichever ones are most appropriate to you. While you're doing the video, I would recommend a bit of music on in the background. It just makes the papers a bit more enjoyable to go through. I always record these with some music on in the background. And if you find this video useful, please do subscribe if you like. And as soon as my paper 2 materials are released, you'll get notified. Right, let's start the paper. Okay, here's the paper, and we will start off. Right, question 1. Solve 6x minus 24 is less than 12. So our first step here is we want to get rid of the minus 24. To get rid of that, we would, well, not get rid of, we want to move the 24 by the inverse of minus 24, which is plus 24. That would give us 6x has to be less than 36. Then we're going to divide both sides by 6, which would give us x has to be less than 6. Okay, question 2. Here are the first 4 terms of an arithmetic sequence. Find an expression in terms of n for the nth term of the sequence. So we've got arithmetic, which means that they're going up by 5 each time. So our term must start with 5n. Then we think about what do we need to do to the number 5 to get to the number 2. To do that, we would need to subtract 3. So we're looking at 5n minus 3. Okay, question 3. Write these numbers in order of size, starting with the smallest number. So we've got a mixture of standard form and decimal. So I'm going to convert these all into being decimals, just because they're easier to convert, to compare that way. So this one is going to become 0.00412. This one is already decimal. This one would become 410. 410. This one is going to become 49800, and then this one is already in decimal. So our smallest number here would be this one, which our next smallest one would be this one. We're then looking 3, 4, 5. So in order, in their original form, we're looking at 4.12 times 10 to the minus 3. 3.15, 4.12, 2.1 times 10 to the power 2, and then finally 1.98 times 10 to the 4. Question 4. Y is directly proportional to x when y is 20, x is equal to 2.5. Work out the value of y when x is equal to 7. Right, so I'm going to look and see whether I can do this with the ratio method. So we've got 30 and 2.5. So what I'm actually going to do is, if it's directly proportional, it means if I double both of these, and then I'm going to divide both of them by 5. So that would be 12 to 1. So if I want to get to 7 here, I'm going to be timesing by 7. So I want to do 12 times by 7, which would give me 84. So let's just say times by 2, divide by 5. There and there. So I'm going to go 84. There is nothing wrong, and probably the more common method is to use the equation of proportionality. So if y is proportional to x, it means y is equal to kx. And I'm going to check with this method because it's just useful to double check. Plus, as I wrote these questions, I'm not 100% certain of all of the answers. I haven't worked them out before. So we'll see. It's a good way to check. So I want to do 30 times by 2.5. So 30 times by 2.5 is going to be 75. Sorry, I've done that wrong. That's not good, is it? Divided by 2.5 is going to be equal to k. 30 divided by 2.5 is going to be not the easiest, so I'm going to do 60 divided by 5, which would give me the 12 that I worked out earlier. And then I'm going to say then that y is going to be equal to 12 times by 7, which is what we did here as well. So that would be 84. Double checked with a second method. Question 5. The diagram shows the plan of a floor. Petra is going to cover the floor with paint. She has 5 litres of paint. There are 1.5 litres of paint in each tin. Petra thinks that 1 litre will cover 10 metres squared of the floor. Assuming she is correct, does she have enough? So I'm going to work out the area of the floor first of all. So the area is going to be equal to these two rectangles added together. So I'm going to say that the area is going to be equal to 7 times 6 plus, if that length there is 6, that length there must be 6 as well. So plus 6 times 4, which gives me a total area 7 times 6, 42 plus. Actually, what I could have done is, let's just say that that's going to be 6 times by 4, 7 plus 4. So that's going to be 6 times by 11, which would give me 66 meters squared. So that's the area that she needs to cover. Right, she's got 5 lots of 1.5 times by 10. So the paint that she has, so has paint for 5 times by 1.5 times by 10. So we're looking at 15 times by 5. So she's got 75 meters squared of paint. So assuming that she is correct, does she have enough? Yes, 66 is greater than 75. Right, part B. Actually, 1 litre of paint will cover 11 meters squared of floor. Does this affect your answer to part A? So all that means then really is that we would be timesing by 11, so we'd have an even bigger number here. So does this affect my answer? No. She will have even more paint. Okay, question 6. Martha plays a game twice. The probability tree diagram shows the probability that Martha will win or lose each game. Find the probability that Martha will lose at least one of these games. So losing at least one would be those 3 branches. I could work each one of those out independently and add them together. But to make it a bit easier, what I'm going to do is I'm going to say if that's the only branch, what I would do is it's going to be a probability of at least one win. So probability that win is at least greater than or equal to 1 is going to be equal. Sorry, the loss is greater than or equal to 1 is going to be equal to 1 minus the probability of winning both matches. Winning both matches, winning both games. So that's going to be 1 minus 5 over 9 times by 4 over 7, which becomes 1 minus 20 over 63, which will give us 43 over 20, 43 over 63. 43 over 63. Question 7. Work at 3 2/3 plus 2 3/7. So for this, what I'm going to do is I'm going to split them into number part and fraction part separately. That's just my preferred method for this. So I'm going to split that to 3 plus 2, and then my fractions are the lowest common multiple of 3 and 7 is going to be 21. So I'm going to convert them to both being equivalent fractions over 21. So the first fraction needs to be times by 7, so that's going to become 14. And the second one is times by 3, so that's going to become 9 over 21. Now, 3 plus 2 would give me 5, and then my fraction part would become 23 over 21. So 21 goes fully into that 23 one more time, which needs to be added to the 5, so that's going to become 6 and 2 over 21. Okay, part B, work out 2 2/4. So that's poor formatting from my part. That shouldn't really be, that's an unsimplified fraction. Divided by 3 over 5. So what I'm going to do is convert that to 2.5 first of all, divided by 3 over 5. Right, so if I convert that to an improper fraction, 2 times 2 is 4, plus 1 is 5, so that's 5 over 2. And then dividing by a fraction is the equivalent to multiplying by its reciprocal, so 5 over 3. And then I was checking to see if I could simplify anything. I can't, so that's going to become 25 over 6. And then 6 goes into 25 fully 4 times with 1 left over, so it's going to become 4 and 1/6. Question 6. Sam has 10 parcels. The mean weight of the 10 parcels is 3.2 kilograms. The mean weight of 4 of the parcels is 2.8. Work out the mean weight of the remaining 6 parcels. Okay, so for this then I'm going to be doing, first of all, I'm going to say that if they have a mean weight of 10, I'm going to do 10 times by 3.2, which would be 32. I'm also going to do 4 lots of 2.8, so 4 times by 2.8, which is going to give me 4 times by 8, 16, 32. 4 times by 3, 4 times 2 would give me 11.2. Right, so the remaining 6 parcels are going to have a weight of 32 minus 11.2, and then I'm going to have to divide that by 6. So 32 take away 11.2 is going to give me 20.8, and I want to divide that by 6, which I think is going to give us a very nice number. Right, so if we do 6's into 20.8, and I'm going to add just a couple of zeros here just as kind of placeholders for myself. Right, so 6 goes into 20 fully 3 times with 2 remainder, and then 6 goes into 28 fully 4 times with 4 remainder. And then 6 goes into 48 fully 6 times with 4 remainder. So we're going to have this reoccurring pattern here, decimal point there. So find the mean weight. I'm going to go 3.4, and rather than write 6 reoccurring, I'm going to go 7, 2 decimal places, one more than the question. Question 9. H is inversely proportional to P, so H is equal to 1k over P. Q is directly proportional to W squared, so P is equal to KW squared, just to start me off. Okay, and we want to, given that H is equal to 5 and T is, oh gosh, that's poor on my behalf. That should be W. So I've messed up there with that formatting. Sorry about that. Right, so let's start that off. Start with this formula. So we'll start with this one. That says that 5 is going to be equal to K over P. So K would be equal to, not P, sorry, 6. K would be equal to 30. So our formula there would have been H is equal to 30 over P. Right, and now if I look at if I look at equation 2, so equation 2, 6 is going to be equal to K times by 49. K is going to be equal to 6 times by 49. Well, 6 times by 50 would be 350. What am I on about? I'm dividing by, so that would be 6 over 49. So our formula here then is going to be P is equal to 6 over 49 W squared. Right, we want H in terms of W, so we want to get rid of our P's. So H is going to be equal to 30 divided by 6 W squared over 49. So we times, so that becomes 30 times by 49 divided by 6W squared. I'm going to tidy that up a little bit first of all. So let's change pen color for that. So I'm going to say that 30 and 6 are both divisible by 6. It will go 5 times there and once there. So I just need to do 5 times by 50 times by 49. So 5 times by 49 is going to be the same as 5 times by 50 take away 5. So it's going to be 250 take away 5. So that's going to be 245. So 245 over W squared. So my formula for H in terms of W is going to be then that, somewhere answer line, H is going to be equal to 245 over W squared. Okay, question 10. Table shows the amount of snow in centimeters that fell each day for 30 days. Oh, I'm just panicking here. That doesn't add up to 30. Adds up to, just realized as I was doing it that I should have checked that. 10, 20, 26. Okay, so I want to take the midpoints here then and times them by the frequencies. So I'm going to say 5, 15, 25, 35, and 45. So if we times them together and then add them up, so 5 times by 7 is going to give us 35, plus 5 times by 15 is going to give us 75, plus 25 times by 10 is going to give us 250. 35 times by 5 is going to give us 105, and then plus 45. So we then need to add those up. Let's do it in pairs. So 35 plus 75 is going to give us 110. I'm going to add these two up next, and that's going to give me 150 plus 250. So that's going to give us 300, 400, 510. Right, so I want to do 510 divided by 26, and that's my fault. I should have adjusted this to make 30. I didn't spot that, which isn't a massive issue. So what I'm going to do is I'm going to say that that's going to be the same as if I halve both those numbers, that's going to become 255 over 13. Right, so I need to say how many times does 255 go into 13? 13 is a prime number, so I've got to do that division. And again, I've made that harder than I should have. 255. So 13's going to 25 fully once with 12 left over. Right, and that's going to go in 9 times because 130 would be 10, so it's 5 less. So that's going to go in 9 times, and we're going to be left with 8. So it's going to be 8 over 13. I'm going to leave that as my answer. 19 and 8/13. If I go decimal, I'm not going to get a very pretty number. We could do the start of it, so it would be 19.8/13. 8 goes into 13 fully 6 times, so 19.6 would be okay. Okay, question 11. So simplify fully. So we're going to factorize the both parts of this. The first one's quite nice because we can take 3x out as a common factor, and that will become 3x times by x plus 5, which we're going to assume is going to be a factor of the bottom line, as long as I've thought this out properly. So we need the other bracket. To make a 4x squared, we must have a 4x there. To give us our 4x squared, and then we'll say that would need to be a -1 to give us the -5, and we'll see whether the other part works. So 4x times by 5 would give us 20, and then 20 take away 1 would give us 19. So that does work. So we're then going to simplify that by taking those, by cancelling those, and it leaves us with 3x over 4x minus 1. Question 12. S is equal to ut plus a half at squared. Find the value of s when u is 5, a is 3, and t is -2. So s is going to be equal to ut, so that's going to become 5 times by -2. Whenever I substitute, I put my negatives in brackets. Next part fully explains why. And that technically should have been a half, but not to worry. Plus 12 times by 3 times by -2 squared. Right, so then 5 times by -2 is going to give us -10. Plus 12 times by 3 times by -2 squared is 4. So that's going to give us -10 plus 12 times 12 is 144, so that should actually give us minus 134. Sorry, talk about minus. That should give us 134. Okay, part B. Make A the subject of s is equal to ut plus 12 at squared. If we're trying to make A the subject, my first thing is to get rid of my, I want to get it by itself eventually, so I'm going to get rid of the st first of all. So that's going to become s minus ut is equal to, and I'm going to slightly rewrite this 12t squared times a. And then I'm just going to divide through by 12t squared. So that's going to give us then that a is going to be equal to s minus ut all divided by 12t squared. Question 13, write 9.34 times 10 to the minus 4 as an ordinary number. So I'm going to be adding 4 zeros at the front. 2, 3, 4, 9, 3, 4. Right, part B, work out the value of. So to do this, I'm going to treat my number and my indice part separately. So I'm going to treat it as 3.78 divided by 6 times by 10 to the power 6 divided by 10 to the power minus 2. Okay, so that division's slightly harder than the original, so I'm going to go 6's into 3.78. So 6 does not go into 3, so we've got 0 point, and then we've got 3 there. 6 is going to 37 fully 6 times. So 6 times 6 is 36, so there's a difference of 1 remainder, and then 6 is going to 18 3 times. So that's going to give us 0.63 times by 10 to the, and then when we do this, we subtract the power, so that's actually going to be 10 to the 8. And then we need to then convert that. That number would be, equals, that's actually going to be 6.3 times 10 to the minus 1 times by 10 to the 8, which will give us 6.3 times 10 to the 7. Question 14. There are only n orange sweets and 2 white sweets in a bag. Sarah takes at random a sweet from the bag and eats the sweet. She then takes at random another sweet from the bag and eats the sweet. Show the probability that Sarah eats 2 white sweets is 2 out of n squared plus 3n plus 2. So I hope this works out. Right, so n sweets and 2 white sweets, so orange to white is n to 2, which means that there's a total of n plus 2 sweets in the bag. So to start with, the probability of taking a white sweet would be 2 out of n plus 2. The second time, so the probability of a second white, there are no longer 2 white sweets, there are now only 1 white sweet. And there are no longer n plus 1 sweets. There are now, sorry, there are no longer n plus 2 sweets. There are only n plus 1. So if I multiply these out, that would give me 2 over, if I put it in brackets just to help me multiply it out, so that would give me n squared plus n plus 2n, so plus 3n, and then 2 times 1 plus 2. So there we go. That's shown it. Okay, question 15. Make f the subject of the formula. So to do that, I'm going to multiply 5 minus f by, I'm going to multiply both sides of the equation by 5 minus f, and I'll expand this bracket as well at the same time. So that would give me df, it will give me 5d minus df is equal to 4f minus 3 minus 12. Right, I'm going to move my f's towards the right and other parts towards the left. So to do that, I'm going to add 12 and add df to both sides. So that would give me 5d plus 12 is equal to 4f plus df. I'm then going to factorize the right hand side to give me 5d plus 12 is equal to f times by 4 plus d. I'm then going to divide both sides by 4 plus d, and that would give me, if I switch sides as well, 5d plus 12, all divided by 4 plus d. And you could have had these the other way around, that's absolutely fine. So it could be 12 plus 5d or d plus 4. Question 16, prove that 0.396 can be written as 44 over 111. So to prove this algebraically, I'm going to start by saying that x is equal to the original number, 396, recurring there and there. I'm going to times 3 by 1,000 because that will get my decimal digits repeating. So 1,000x is going to be equal to 396.396. Right, I'm going to subtract one from the other, so I'm going to say that 999x is going to be equal to 396. So x is going to be equal to 396 divided by 999. I'm then going to simplify. I'm going to assume that these are both divisible by 9. So let's just double check that. So if I put it over 111 and do 9s into 396, so 9s go into 39 fully 4 times with 9 times 4 is 36, so there's 3 left over, and then 9's going to 36 fully 4, so it will be 44 over 111, which is what we were asked to show. Okay, question 17. A, B, and C are points on a circle. Work out the size of angle X. Okay, so just checking. So BD is a tangent to a circle, and the tangent meets the radius at a 90-degree angle. So the way I'm going to do this is I'll kind of do it on the diagram first of all. So I'm going to use the circle theorem that the angle at the center is twice the angle at the circumference to say that that's going to be 64. And then I'm going to use angles in a triangle to work out X. So I'm now going to explain that a little bit more. So OBD is equal to 90 degrees. Tangent and radius meet at 90 degrees, and it doesn't ask for the reasons, but I'm just going to include them anyway. And I'm going to say that BOD is going to be equal to 64. I'll actually go a step further and say 2 times by 32, which is equal to 64. And then angle at center is twice angle at circumference. And then I'm going to say angles in a triangle add up to 180. So in effect, D. So X is, I'm just going to say 90 minus 64. The reason being is technically I would be doing 180, take away 90, take away 64, but I know 180 take away 90 is 180 take away 90 is 90, so I'm just treating it as 90 minus 64, which is going to give me 26 degrees. And my reason there is angles in a triangle equal 180 degrees. Question 18. Amy and Ben drive along the same 90-kilometer road. Amy took 2¼ hours to cycle 90 kilometers. Ben started to drive 5 minutes after Amy started to drive. Ben caught up with Amy when they had both driven 30 kilometers. Amy and Ben both drive at a constant speed. Work out Ben's speed. Okay, so Amy took 2.25 hours to cycle 90 kilometers. So I'm going to say time and distance. So in 2.25 hours, she did 90 kilometers. So I'm going to times both these. I'm going to times by 4 here to get rid of that. So 2.25 times by 4 would be 9. And then 9 times by 4 would give us 360. So in 1 hour, they would have driven 40 kilometers. If in 1 hour she would drive 40 kilometers, I want to find out how long it would take her to drive 30 kilometers. So I'm going to say, I'm going to go for, I'm going to build up to 30 like this. I'm going to say that if I divide by 4, that would be 1/4 of an hour to do 10 kilometers. So it would be 3/4 of an hour to do 30 kilometers. So 3/4 of an hour is going to be 45 minutes. 45 minutes to travel 30 kilometers. Right. So if Ben started 5 minutes afterwards, Ben, so this is actually Amy. Now, if I start to look at Ben, so Ben travel, so Ben caught up with Amy after they both travelled 30 kilometres, but Ben set out after 5 minutes. So Ben has only been travelling for 40 minutes to hit this 30 kilometres. So I want to build that up to 60. The way I'm going to do that is I'm going to say that in 20 minutes he would have travelled 15 kilometres. So in 60 minutes he would have travelled 45 kilometres. So Ben's speed is 45 kilometres per hour. Question 19. Here is a trapezium ABCD. The area of the trapezium is 90 centimeters squared. The length of AB to the length of CD is 325. Find the length of AB. Okay, so I'm going to call AB 3x and say that CD is then 5x. What else do I need? I need the vertical height for the area of a trapezium, which I will call lowercase h for a moment, and say that that's a right angle there. So I'm going to be using an exact trig value here. So if I look at this right angle triangle, this would be the hypotenuse. So I'm going to call that capital H, and this would be the opposite side. So I'm using the sine ratio. Sine is opposite over hypotenuse. So this case, though, I'm trying to work out O, so I want that O is going to be equal to sine of the angle times by H. So let's substitute in then. H is going to be equal to the sine of 30 times by the hypotenuse times by 6. I know that sine of 30 is a half, so the height is going to be equal to a half of 6. So that would, I'll put in half times by 6, which would be 3. So the height of the trapezium is 3. Right. The area of a trapezium is equal to a half of A plus B times by H. So that means that 90 is going to be equal to a half of 3x plus 5x times by 3. I am going to get rid of this 3 by dividing by 3 first of all. So that's going to give me 90 divided by 3 would give me 30 is equal to a half of 8x. So is equal to 4x, which means that x is going to be equal to 15 over 2. Right, we didn't actually want x though. We want the length AB, which is 3x. So I'm going to say that 3x is going to be equal to 3 lots of 15 over 2, which would give me, if I say that's 7.5, that's going to be 7.5, 15, 22.5. Is it 22.5? Right. Question question 20. So rationalize the denominator. So to rationalize the denominator, I'm going to times through by root 13 over root 13. So that is going to give me 26 root 13 divided by 13. And then 26 divided by 13 is 2, so that's just going to be 2 root 13. Okay, part B, show that root 5 divided by 3 root 5 plus 1 can be written in the form a minus root 5 over b. So I'm going to be using kind of completing the square, sorry, a difference of 2 squares to rationalize the denominator. So I'm going to times through by 3 root 5 minus 1 on the top and the bottom. So 3 root 5 minus 1. So that's going to give me on the top line root 5 times by 3 root 5 would just give me 3 times 5 minus root 5, all divided by 3 root 5 times 3 root 5 would give me 9 times 5, so that would be 45, and then minus 1. So that's going to give me 15 minus root 5, all divided by 44. Question 21, prove algebraically that x can be written as. Okay, so again, a bit like before, we've already got x there, so I'm going to times by 100 to start with and say that 100x then is going to be equal to 45.8585. Right, now I've got my decimal pattern happening, repeating in the third and fourth decimal place. So I'm going to subtract one from the other and say that 99x then is going to be equal to, so 5 take away 5 is 0, 8 take away 4 is 4, and then 45, so 45.4. So x is going to be equal to 45.4 divided by 99. The 0.4 is not a particularly easy one to get rid of. So I'm going to get rid of the decimal first of all by timesing the numerator and denominator by 10. So that's going to be x is equal to 454 divided by 990. I'm then going to go and halve both numbers. So that would give me 227 over 495, which is what we were asked to show. So there we go. Okay, question 23 then. Simplify. So the first top line is already simplified. So x plus 3. The denominator, though, I'm going to start by taking out a factor of 3. That would give me x squared plus x minus 6. Then we're going to factorize that. So I'm going to hope that this will go into 2 brackets nicely. So I'm going to assume that one of them is x plus 3, just to help me out a bit. Because if it's going to be simplified, we would assume that. So x plus 3, and then to get x minus 6 here, I would need an x and a minus 2. And then just double checking, 3 times by minus 2 would give me the minus 6, and then plus 3 minus 2 would give me the plus 1. So that does factorize, and then we can simplify that. So that's going to give us 1 over 3 lots of x minus 2. Just as a slight note, the original version that I had here had a minus 3. So if you've got that original version, That's my fault. When I did a quick QA, I spotted that I'd not worked that out properly. Right, part B, factorise fully. So again, we're going to use this difference of two squares, and we are going to take out a 3 as a common factor. So that would be 3 times by 16 minus y squared. So that's going to be 3 lots of 4 plus y times by 4 minus y. Okay, question 23. A bakery makes 600 cakes each day. The cakes are either chocolate or vanilla. A quality inspector takes a sample of 20 cakes each day. The proportion in the sample reflects the production ratio. On Monday, the inspector found exactly 8 chocolate cakes in his sample. Work out the total number of chocolate cakes made that day. Okay, so 8 out of 20 needs to be equivalent to the number of chocolate cakes made out of 600. So if we treat that then as how we can simplify this is up to us. So I'm going to start by saying that that's going to be actually the same as if I divide both of them by 4. That would be 2 out of 5 is equal to x over 600. So I'm going to say that x is going to be equal to 2 times by 600 divided by 5, which is going to be 2 lots of 60 divided by 5 would be 12, so that's going to be 120. So I'm looking at 240. Okay, part B. On Tuesday, the number of vanilla cakes in his sample is recorded as 9. Correct to the nearest whole number. Work out the lower bound for the probability that a randomly selected cake made on Tuesday is vanilla. Okay, so the lower bound for the probability that a randomly selected cake made on Tuesday is vanilla. So we're going to take this. I think this is actually arguably an issue with the original question, but we'll follow the same process. So I'm going to take, if I'm saying 9, I'm going to take the lowest bound as 8.5, and I'm going to say that 8.5 out of quality inspector takes a sample of 20, so out of 20. And then I'm going to work out what the probability is. So the probability is going to be equal to 8.5 divided by 20. I'm going to say that's going to be the same as, if I halve that, that would be 4.25 out of 10. So that's going to be 0.425. Right, question 24. Here are the first 5 terms of a geometric sequence. Work out the next two terms in the sequence. Okay, so for this, we are, the pattern or the common ratio is divided by 2. So our next term is going to be 1 over 2. And then our next term is going to be 1 over 4. So 1 over 2 and then 1 over 4. Right, so first term of a different geometric sequence is 128. The sixth term is 32. Given that the terms of the sequence are all positive, work out the first term of the sequence. So if we actually call the first term A, then what we're doing to get to the next term is times in by R. So the fourth term would have actually been, so if we think about it, the first term would be A, first term, the second term would be AR, second, third term would be AR squared. So the fourth term would be AR cubed. So AR cubed is equal to 128, and AR to the power 5 is going to be equal to 32. So that's the fourth term, that's the sixth term. So if I want to work out, really I want to work out R. So what I'm going to do is if I divide six, treat them as two separate equations, and I'm going to do equation 1 divided by equation 2. So that's going to give me R squared is equal to 32 over 128. That actually means 32 is a factor of 138. It's 4 times 138, because if we think 32, 64, double it again, 128. So that means that R squared is equal to 1 over 4. So R must be equal to 1 over 2. Right. Okay, and we're actually after the first term here. So what we can actually say then is we know that if I substitute that into this one, so I know that A times by 1 over 2 cubed is equal to 128. That means that A times by 1/8 is equal to 128. So the first term must be equal to 8 times by 128. So 8 times by 8 is 64. 8 times by 2 is 16, plus the 6 is 16, 22. And then 8 times by 1 is 8, plus the 2 is 10. So I'm looking at 1024 for my first term. Right, question 25. Write this as a single fraction in its simplest form. Right, so I want to put it over the same denominator. The denominator is going to be these two terms multiplied, so x times by x plus 1. To do that, I would need to times the 5 by x plus 1, so that would give me 5x plus 5. And then I'd need to times the second fraction by x, so that would be 2x. So that should give me 7x plus 5 over the denominator of x times by x plus 1. Okay, the second part then, factorize 2x plus 3y squared minus 3 lots of 2x plus 3y. So I'm going to take 2x plus 3y out as a common factor. 2x plus 3y, and then I would then need to times that by 2x plus 3 minus 3. And then they would cancel, and that would just leave me with 2x times by 2x plus 3y. Okay, part B, factorize. So I'm going to take out 3x plus 2y as a common factor. So 2x plus 3y, and I would need to times that by 2x plus 3y. And then minus 3. And that's going to be my factorized version. So that's going to be my answer. Right, question 26. A box contains only red and yellow markers. There are 4 more yellow markers than there are red markers, and there are more than 15 markers in total. 2 markers are drawn at random without replacement. The probability that both markers are the same color is 0.5. Work out the number of red markers in the box. Okay, so let's try and get our head into this. So 2 markers are drawn without replacement. The probability that both markers are the same color is 0.5. So that means that the probability of them being yellow and yellow, or probability of them being red and red, probably should have done that the other way around, is equal to 0.5. Right, so if we look at, it doesn't really matter which one I do first, if I look at the probability of them being red and red to start with. So we have got there are far more yellow than red markers. So the probability of picking a red marker first of all then is going to be, well, I don't know that number yet. So if I use R to stand for the number of red markers, there are far more yellow markers than red markers, so it doesn't really matter which way I do it. Let's go R. So the probability of picking a red marker the first time is R divided by 2 lots of R plus 4, so 2R plus 4. And then the probability of picking a red marker the second time is now R minus 1 divided by 2R plus 3. Right, and we can do that multiplication. Is it worth doing it just yet? Yeah, we'll do it. So that would give me R times by R minus 1 multiplied by 2R plus 4 times by 2R plus 3. Right, and the probability of picking 2 yellow markers. So I think I should have been a bit more careful about my working space, so I'm going to try and do it over here. So the probability of yellow and yellow, so PYY is going to be equal to, we've got R plus 4 divided by 2R plus 4 times by R plus 3, no, yeah, R plus 3 times by 2R plus 3. So that's going to give me then R plus 4 times by R plus 3, all divided by the same denominator. So 2R plus 4 times by 2R plus 3. Right, so these add together to make 0.5. And we have the same denominator for both as well, which is slightly handy. So if we add these together, we can just add the numerators together. So we've got, in effect, R times by R minus 1 plus R plus 4 times by R plus 3, all over that denominator of 2R plus 4 times by 2R plus 3. And that's going to be equal to a half, or 0.5. I'm going to go half. Right. So if I multiply through by the denominators and probably by 2 as well, that might tidy things up a little bit. I'm going to do it by R, and I'm going to run all of my brackets as well. So that would give me R squared minus R plus R squared plus 7R plus 12, and that's going to be equal to, and I'll put the 2 there, and then if I expand this bottom line, that's going to give me 4R squared plus 6R plus 8R. 6 plus 8 is 14R plus 12. Actually, I'm going to re-put that divide by 2 here because everything there is divisible by 2. Let's just check I've multiplied that outright. So 2R times 2R would give me 4R squared. 2R times by 3 would give me 6R plus 8R. 6 plus 8 would be 14R. And then 4 times 3 would give me 12. Right, let's tidy that up a bit then. So that would give me 2R squared plus 6R plus 12 is equal to, and if I divide this by 2, R squared, 2R squared plus 7R plus 6. And this simplifies really nicely, actually. So 2R squared, but 2R squared, they cancel. So what I would need to do is minus 6R from both sides and then add 6. So that would give me 6 is equal to R. So I make it 6 red markers. I've just had a bit of a panic though, because there was this, there are more than 15 markers in total. Just checking though, there are 4 more yellow markers than red markers. So that would mean actually in the box there are 6 plus 6 plus 4, which would give us 16. So we have got more than 16 markers in the box. So R would be equal to 6. Okay, that brings us to the end of the paper. I'll bring up the question level analysis from the original paper. And that will give us a kind of an idea of grade boundaries. Although because this was a made-up paper by me, I adjusted the numbers. We're going to find that we can't necessarily say these are accurate grade boundaries. Okay, so those are the rough grade boundaries for this paper. Well, technically, those are the rough grade boundaries for the original paper. Obviously, because I've adjusted the questions, that they would not necessarily hold fully true. The chapter index for this video will reference these as the skills tested, or the topics that they're on. So if you found one of those questions particularly challenging, please do focus a little bit of extra time on your revision on those areas. The paper has been arranged by difficulty on purpose to make it a progressive paper. I hope you found that useful. If you've got any questions, comments, or feedback, please put them into the chat to this video and I'll get back to you fairly quickly. I'm fairly prompt with that kind of thing. Thanks very much again for your time. I hope the rest of your revision goes well. Good luck, and I will see you soon.